Lesson 24 Project Help Video. When Sally and Chelsea, the pterodactyls, are flying at their cruising height, they don't actually stay at exactly the same height all the time. With every wing beat, their height rises just slightly, and with every glide, their height falls just slightly. This results in motion that for Sally is represented by a sine function and for Chelsea is represented by a cosine function. The points in the following table are on the graph of Sally's motion, which corresponds to the function g of x equals 2 sine x plus 15. So we're going to go ahead and we're going to graph the function, and then on your project you click the tool and you drag the points to where they need to go exactly, and then when you're all done you hit check answer, and then if it's correct it will give you the code. You put that code exactly how it's written, capital letters, everything, into the box. If you don't get it correct and it tells you oops, try again, keep trying until you get the code. So the first point, point A, is at negative 3 pi over 2. So I'm going to go negative 3 pi over 2 and then up to 17. So here is point A. Point B is at negative pi 15. So here is my point B. Point C is at negative pi over 2, 13. There would be my point C. Point D is at 0, 15. Point E is at pi over 2, 17. Point F is at pi 15. And then point G is at 3 pi over 2, 13. And then I would just connect my points. So you see that it's a very slight sine function, but it is a sine function nonetheless. So I would plot these points, and then I'd hit the check answer button, and I'd end up with, it would have my line there drawn in. So here's a better of what the function actually looks like. And then it would give me good job, your code is pterodactyl 17. So then I would take this pterodactyl 17 and plug it in as my answer on my project. Exactly, capital letters and numbers, everything that it gives me exactly. Hope this helps with your lesson 24 project.